Very good morning to one and all gathered here. In today's lecture series, we are going to see basic numerical illustrative problem on work transfer concept. In the previous session, we saw about heat transfer fundamental. And also I told you that in the next meeting, we will be solving some few basic problems on work transfer equation with a sample illustrative framework. So with that continuation, now we are going to discuss the work done by the system and surrounding the interaction between these two things with the help of a simple numerical case study. So let us take the given problem. Consider a helium gas which is compressed inside the bottle and it is used to inflate an inelastic flexible balloon originally folded completely flat to a volume of 0.5 meter cube and the barometer pressure reads to be 760 mm of mercury. What is the amount of work done by the system? And sketch the system before and after the process. So, what are the variables that are given in the problem? Atmospheric pressure and the final volume of gas, 0.5 meter cube. So based on this, now we have to find out what is the work done by the system with respect to the atmosphere surroundings. And it is required to sketch the system considering before and after the process, before work done and after work done. So let us see the illustrative graphical mapping for the given problem solution. So this is the gas bottle. Inside the bottle, inside the chamber, the helium gas is tightly compressed and filled within it. And this is the closing wall, opening and closing wall for releasing the gas through the passage in order to fill the gas inside the balloon, the empty volume, the space occupied inside the balloon. Okay, this is the problem framework that has been sketched according to the characteristics of the system. Now, here, initial volume of the balloon, here V1 is 0. From the problem, it is given that the initial condition is considered to be completely flat. The balloon lies completely flat, 0 volume. Whereas V2, final volume, 0.5 meter cube. So here the gas is filled inside the balloon. So it is getting erected. So this is the final displacement position of the balloon compared to the initial displacement. So V1 is 0 and V2 is 0.5 meter cube. P1, P2 are the initial and final pressure. And P is the atmospheric pressure that is converted in terms of kilopascal. Now we are going to apply the equation, the displacement work done by further proceeding the problem. Here, work done by the system comprised of two components, say work done by the balloon and the work done by the gas bottle. So these are the two things we need to add as a net work done by the system. So that this is the total work done equation by the system. So work done by the balloon and work done by the bottle. Integral PdV. Okay. So now let us solve for work done by the balloon. So P into V2 minus V1, where V2 minus V1 is the change in volume, or we can say delta V, where P is the atmospheric pressure. But here, the wall of the bottle, the gas bottle, is very rigid and fixed, so there is no work done. So it is 0. So that information is given in the next slide. wall of the bottle is rigid. There is no PDV work done involved in it. So it is considered to be zero work done. Only in the balloon, the work transfer takes place by allowing the gas to flow inside the balloon. So there are two volume, initial volume, final volume. Initial volume is 0 and final volume is 0.5 meter cube. So substitute this value in the formula P into V2 minus V1. So you will get the net work transfer in terms of kilojoule, 50.66 kilojoule. So what are the observations from the given solution? So this is the positive work done because it's work carried out only by the system. The work done is performed by the system. So the work done by the atmosphere is considered to be negative. But if you take as a whole a complete system, it includes both gas and balloon, the work done by the gas and balloon. So therefore, the displacement work calculated to be 50.66 kilojoule as found from the previous slide. So with this, I thank each and every one of you for your continuous support and encouragement. So kindly share the link, channel link to your close neighbor contact. So in the next meeting, we will see some other subject, new area in mechanical engineering. So thank you one and all present here.